Okay, now we're going to learn how to add the enzymes to our glycolysis steps, because in the previous video we learned how to draw them, and now we're going to see how to figure out what the enzyme names are. So in adding enzymes to glycolysis, there are two helping devices that we use. We use 222 and we use Mad Ike, and this is Mad Ike over here. Now normally, and we'll see this in Krebs cycle later on, if an enzyme is properly named or systematically named, you'll see the name of the compound that's reacting, the compound that's on the left side, and then the enzyme name will include the action that the enzyme is taking. For example, when we change glyceraldehyde 3-phosphate into 1,3-bis-phosphoglycerate, we need to figure out what the name of that enzyme is. Now, one of the systematically named enzymes in glycolysis, and there are two, but one of them is glyceraldehyde 3-phosphate. When that's a reactant in glycolysis, you're going to see its precise name, glyceraldehyde 3-phosphate, in the enzyme name. In this example, we see the compound name, glyceraldehyde 3-phosphate, and then following that, we see the action that the enzyme is going to take. And we'll get to that in a little while with Mad Ike. But for now, I'll tell you it's dehydrogenase. The action the enzyme name is telling you is we're going to be removing a hydrogen from a carbon in the reactant. Now, only two of the enzymes in glycolysis, this is our 222 rule, only two of the enzymes in glycolysis actually name a specific compound. Those two compounds that are specifically named are glyceraldehyde 3-phosphate, which we just looked at. The other compound that's specifically named is pyruvate, and we see pyruvate in the last step in glycolysis. So in step 10 of glycolysis, when we're changing pyruvate, PEP, phosphoenolpyruvate, to pyruvate, now the enzyme name should have PEP in it because that's the reactant. But in this case, the pyruvate is named in the enzyme. So we see the enzyme name is pyruvate. The action is kinase. We didn't learn that yet, but you'll come to see that a kinase means we're transferring a phosphate group from a whole other compound. So the first two in 222 stands for the two enzymes that keep the actual specific compound name in the enzyme name. Now let's look at the second two in 222. The first two are the enzymes that keep a specific compound name in the enzyme name. The next two we're going to look at refer to compounds that have nicknames. And there are two compounds that have nicknames in glycolysis. Our alpha-D glucose has a nickname, and that nickname is hexo. The other compound in 222 that has a nickname is DHAP, dihydroxyacetone phosphate, and that has a nickname also. Its nickname is triose phosphate. Triose is telling us it has 3 carbons, but we already knew that. So far we know in the 222 rule, if you see glyceraldehyde 3-phosphate, that's going to be in the compound name as a reactant. And and if you see pyruvate, that's going to be in the enzyme name as the product. The second two in 222 tells us the compounds that have nicknames, and we know there are two compounds that have nicknames: glucose, whose nickname is hexo, and DHAP, whose nickname is triose phosphate. So we're up to the last two in the 222 rule, and this refers to the two enzymes that have no compound name in them at all. And these two enzymes are aldolase and enolase. So let's look at where we see aldolase happen. When we have the compound fructose 1,6-bisphosphate, let's draw that quickly. We have a phosphate on 1, and a phosphate on 6. In this step of glycolysis, we remember that we're going to cut here and here. So we're going to turn our 6-carbon compound into 2 3-carbon compounds. DHAP and glyceraldehyde 3-phosphate. To get from here to here, we're cutting carbons. An aldol refers to reactions where you're adding carbons to a compound, or you're cutting carbons off of a compound. So that's aldolase. So aldolase and enolase are the two enzymes with no compound names. Now you already know what an enol is. Here's our 2,2,2. And we're talking about enzyme names that have no compound names in them. When you're making an enol, the enzyme is going to be enolase. And we see that we're making an enol in the 9th step of glycolysis. And let me draw that out for you. When we go from 2-phosphoglycerate to phosphoenol pyruvate, we're making an enol. The E in PEP stands for an enol. And the enzyme, therefore, that has no compound name at all is enolase. So now we understand there are 2 tools to name enzymes in glycolysis. We've covered the 2-2-2 rule, and now we're going to learn about Mad-Ike. He's not really mad, he's just acting mad so that we can use him to help us in glycolysis. So let's see what MADIKE stands for. The M in Mad-Ike stands for a mutase. This is going to be in the enzyme name. A mutase is a type of isomerase. It's a special type of isomerase. We know what an isomer is. A mutase is a special type of isomer. An isomerase refers to an isomer where you're moving a functional group. When we say mutase, we're still making an isomer, but we're making the isomer by moving a non-functional group. And the non-functional group we're moving in glycolysis is a phosphate. So let's look at that reaction. When we go from 3 phosphoglycerate to 2-phosphoglycerate. The only difference between the two compounds is where we're putting that phosphate group. So these are two isomers, and we're moving a non-functional group. We're moving the phosphate group. So the name of this enzyme is going to be phosphoglycerate kinase. Phosphoglycerate. Let me back up for a second to our 2-2-2 rule and explain to you where that comes from. In the 2-2-2 rule, we have two enzymes with specific compound names. We have two compounds with nicknames, and we have two compounds, enzyme names that have no compounds named in them at all. All the rest of the enzymes will be called phospho something. So let's go back to our reaction. We're going from 3-phosphoglycerate to 2-phosphoglycerate. Well, phosphoglycerate is not one of our specific compound names, so that's not going to be in the enzyme name. And 3-phosphoglycerate is not one of the compounds that has a nickname, because that's glucose and DHEP. And it's not one of the enzymes that's an aldolase or an enolase, because we're not cutting carbons and we're not making an enol. That leaves phospho. We know that this has to, if it's not a 2-2-2, it has to be a phospho something. Since the reactant compound is phosphoglycerate, the compound name in our enzyme is phosphoglycerate. And it's not a kinase at all. We're moving a non-functional group, so it's going to be phosphoglycerate mutase. So that's the M in our MAD-IKE. Let's